So guys, today what I will cover your Palo Alto Firewall high availability related all the questions with answers basically. So here I have chosen around 20 questions on your Palo Alto high availability. So these are the 20 questions. Like here I have put 10 and 10 I have put into my next slide. So these are the around 20 questions which I'm gonna discuss. So let's see how many we can able to cover today, and remaining we will basically, because see these webinars we are having on every Saturday. Okay, so you all will get the Zoom link for every Saturday, so you can join, and basically where we will cover all the things. So I am basically trying to cover all the question on Palo Alto Firewall with regards to the topics. Like today I have picked HA, high availability, right? Maybe in next class I will cover like what is life of a session, then how your URL filtering works. So in URL, what are the questions asked in the interview? What are the questions asked in app ID, right? So I'm basically trying to pick such kind of questions basically. Okay, so without wasting time, let me just start with the first question. What is HA and what type of HA is supported by the Palo Alto Fire? This is a very, very basic question, guys. So let me just answer this one. So HA stand for high availability. Okay. And your Palo Alto Firewall supports two types of high availability solution. First one is active passive, and second one is active. Now, what is the difference between active passive, or how your active high availability works? Let's discuss that thing, guys. So I will take the help of whiteboard. So if you will see, this is the topology which I'm having here, and I hope this topology is visible to you guys, right? So let's suppose this is my firewall 1 and this is my firewall 2. Now let's discuss active passive high availability. So in active passive high availability, what happens? Your one firewall, it will be take the role of active device, and another firewall will take the role of your passive device. Now all the traffic which is initiated by these LAN users, or let's suppose we have some users over the internet, right? And if they want to access these particular servers in your LAN environment, what they will do, all that traffic will be handled by the active device basically. This is known as, and this is your active passive high availability, means your active device or your firewall 1 will handle all the traffic actively, and your passive device, it is just sitting idle. When your active device failed due to any reason, what it will do, that time your passive device, it will take the role of active device, and it will basically start doing the data forwarding. So this is your active passive high availability. Now in Palo Alto Firewall, another type of high availability is your active high availability. In active high availability, what happens? We have this firewall which is firewall 1. This firewall will become your active primary firewall, and your firewall 2 is become the active secondary device. Now in your active high availability, both devices, your firewall 1 and your firewall 2, they will do the data forwarding. Means some machines from your LAN side will forward the data towards your firewall 1, and some machine in your LAN side will forward the data towards firewall 2. Means both device doing the data forwarding at the same time. But just remember one thing with regards to your active passive or active design in your Palo Alto environment. See, first of all, around 95% customers basically, they always go with the active passive design. They never use this active design, guys. Just remember why they will not use the active design. There is a reason behind this. So maybe in your interview they will ask why basically you will not recommend active design, or what is the use case where we can use active design of where we will go with the active high availability deployment of your Palo Alto firewall. So let me just tell you one reason. There is a one small reason. Let's suppose this firewall, or let's suppose when we have both these firewalls, we are running on active passive, and let's suppose throughput of both the devices, let's suppose, is 10 Gbps, and the session capacity of both the devices, let's suppose, is 2,56,000. Now, if you will deploy the same devices on active unit, you will get the same throughput, guys. And you will get the same session capacity, which means there is no increase on the session capacity and there is no increase on the throughput. This is the one of the biggest reason. Basically, Palo Alto is also recommend always go with the active passive design. Now, if they will recommend active passive design, then why we have this active design, guys? So there is a one use case, and we have to understand that use case where we have to go with the active design. So let me just explain that particular use case. So let's suppose you have an environment where I have my firewall 1 here and I have my firewall 2 here. These firewall, they have a connectivity with these HA links. Okay, I'm not putting the name here for now. And after that, you have one router here, maybe router R1. Here we have another router, which is router R2. And this router have a connectivity with the internet service provider, maybe ISP1. This router will also have an internet connectivity with ISP2. And over the internet, because this is your internet cloud, all these ISP, they have a connectivity till here. And after that, here, let's suppose you have one server. This is one server here. Now, apart from that, you also have the environment here. You have router 4 and we have router 5 here. And after that, behind these routers, we are having our LAN environment and our DMZ environment. So let's suppose this is your LAN environment and your DMZ environment. Now, in this environment, let's suppose we have this user. Now, let's suppose this user, he wants to communicate with this server. So let's suppose he's forwarding his traffic. That traffic reaches to R4, then it is going towards firewall 1, then firewall 1 will forward towards R1, then ISP will forward this traffic towards the server. Now, due to asymmetric routing in the environment, basically, what happens when this server, he's sending the reply from different path, because you have some asymmetric environment, guys. So if you have this kind of environment where your request packet will follow one path and your reply packet will follow different path, guys. In these kind of scenario, we have to go with the active design. So your firewall 1 is also active device and firewall 2 is also active device. So this is your active primary and this is your active secondary. And now they can both do the data forwarding and they can both do the load sharing with each other. So this is the only design. So if you have a asymmetric routing environment, in that case only you can go with the active design. Otherwise, active design is not recommended by the Palo Alto as well, guys. Okay, so this is the answer of what is high availability, what type of H is supported by your Palo Alto firewall. Now let me just go here. What is active passive and active? This thing also I have explained. Now let me go here. Let's suppose we have this particular environment, which means how upstream and downstream switches knows when firewall switch over from passive to active unit. Let's suppose we have this particular environment here. So let me go back into my topology. In this topology, let's suppose this device is running as an active device and this device is running as a passive device. Now, due to any reason, this active unit failed. Let's suppose this active unit failed, which means that time your passive unit become active. Now guys, this particular switch, this is a upstream switch and this is your downstream switch. How they will know? They have to basically start sending the data towards this device. What is the mechanism used by these particular firewalls to achieve this thing? So guys, just remember one thing. The answer for this question is simple. Whenever failover happens between your firewall 1 and firewall 2, what they will do? The device who will take the role of active, he will basically sends the gratuitous ARP basically, or we can say it will sends the GR towards your downstream switch, and here also it will send the GR. When he will send the GR, your upstream and your downstream switch, they will update his MAC address table and ARP table, and after that they will send all the data which is initiated by these machines towards your firewall 2. That's how they will basically get to know. They will send the GR. Now let's see this particular behavior, guys. So right now I'm running. So I'm running my firewalls in active unit right now, guys. So I'm running these on active unit. So what I will do, let me just start the capture on one of the interface here, which is gig 0y1. Let me start the capture here. I've started the Wireshark capture. Now, what I will do, let's suppose I will make this device down. And you will see in the Wireshark captures, just wait here. You will see this particular R packet they will send. This is the gratuitous R packet they will basically send towards your switch. So your switch gets to know there is a failover triggered between your firewalls basically. So that's how they will get to know there is some activity happens with regards to your high availability. Okay. So the answer for this question is very simple. They will send the gratuitous ARP towards the upstream and downstream switches. And when your upstream and downstream switches receive the gratuitous ARPs, they will update the MAC address table basically. And after that, they will start sending the traffic towards the other firewall who just become the active unit. Okay. Now, in high availability, they will ask one more question. It's a very, very popular question, guys. What is HA1 interface? What is HA2 interface? Or what is HA3 interface in your Palo Alto high availability? This question, maybe they will ask in this way. What is HA1, HA2 and HA3 interface? Maybe they will ask in this way. What is control interface? Or what is control link? What is data link in your Palo Alto firewall basically? So if you want to answer this question, so just remember one thing. Let me just go here. I have basically this particular diagram, guys. So in this diagram, if you will see, this is the Palo Alto firewall basically. This is your firewall 1, let's suppose. This is your firewall 2, let's suppose. So let me just write down here firewall 2. Now, in your firewall, everyone know they have a management plane and they have a data plane, right? They have a management plane and they have a data plane. So guys, your HA1 interface is your control link, just remember. And your HA2 interface is your data link. Now your HA1 interface is a part of your management plane. And your HA2 interface is a part of data plane. What is the use of this HA1 interface? So we will use this HA1 interface for configuration synchronization, because all type of configuration we will do on your firewall 1, that configuration is automatically synchronized with firewall 2. So it will do the configuration sync. This interface we will also use for sending the heartbeat messages and your hello messages. These heartbeat messages basically exchange between your firewall 1 and firewall 2 through HA1 interface, guys. And now, just remember one thing, why we exchange these heartbeat messages. These heartbeat messages are the ICMP ping messages, guys. These are the ICMP ping messages, and we will exchange these messages between firewall 1 and firewall 2 to tell the state of each other, or we can say to check other devices live or not. These messages also used for checking the health of the other device, means other devices up or running, or it is basically down. How they will basically check? So they will check because they will send the heartbeat messages. If they will miss the heartbeat messages, they will get to know they will get to know other devices failed basically. So that's why they will exchange the heartbeat message. Now these, why they will exchange hello messages, guys. So just remember one thing. So I will cover this question, why they will exchange hello messages, because I want to also tell you one more thing here. So guys, if you know what are the prerequisite basically to configure your firewall 1 and firewall 2 in HA pair, what are the prerequisite? They should have a same mode. So there is some hardware requirement, right? There is some software requirement, there is some license requirement, right? When these requirement will fulfill by both the devices, then only we can able to configure on HA. So let's say what are the hardware requirement. Both firewall will have the same model number, which means if your firewall 1 is 30 to 20, then your firewall 2 should be also 30 to 20. If your firewall 1 is 30 to 20 and your firewall 2 is 30 to 60, in that case we will not able to configure them on a HA pair, means your hardware model should be same. If we have a same hardware model, which means they have a same number and same type of interfaces as well, which means if your firewall 1 he is having 4 fiber ports and 8 copper ports, which means we need a same type of environment or same type of interfaces on firewall 2. It should also have the 4 fiber ports and 8 copper ports, guys, just remember. And after that we have a software requirement. Software requirement means both firewall have a same pan OS version, guys. What? They have a same pan OS version. They have a same dynamic updates. They have a same dynamic updates for your application updates, your application signature updates, your wildfire updates, your thread updates, all these updates, right? They have a same URL filtering license. If firewall 1 is using PanDB, then firewall 2 also be in PanDB only. If your firewall 1, let's say using PanDB URL filtering license, and your firewall 2 is using your, so like there is a two solution. One is PanDB. This is the one of the Palo Alto solution. There is another solution is, this is a third party solution which is owned by the Webroot company basically. Okay. So if they have a same license for firewall 1, which means if it is having URL 4 license, which is your PanDB license, then this firewall also have the same URL 4 license. Okay. So this Webroot solution is also known as Bright Cloud URL filtering solution, guys. Okay. So these requirements should be similar. Both have the same type of license requirement as well, guys. So these are some prerequisites. Now, how basically your firewall 1 or firewall 2, they will get to know they are running the same model number. They have a same hardware. They have a same pan OS version. How they will get to know? They will get to know because through this control link or through HA1 link, they will exchange these hello messages, guys. They will exchange these hello messages. That's how they will get to know they are having the same same hardware software licenses on both the firewalls or not. How they will get to know? Your firewall one, it will send the hello message with some kind of MD5 hash values. If there is a mismatch with regards to version, dynamic updates, license, that MD5 hash value will mismatched. So that's how they will get to know these things. They will exchange through these hello messages, guys, through your HA1 interface. Now, let me just go here. Your HA2 interface is known as data link, basically. This interface is used for session synchronization, your forwarding table synchronization, your IPSec security association synchronization, your ARP table synchronization. And just remember, your HA2 interface we can configure as a layer 2 or as a layer 3. But your HA1 is always a layer 3 interface, guys. And your HA1 interface on firewall 1, it will communicate with firewall 2 using the TCP port number 28 when we enable the encryption between with that communication which is happening through HA1 interface. Otherwise, by default, it will use port number 28769. Your HA2 interface, basically, we can configure layer 2, layer 3. If we will configure on a layer 3, that time what it will do? It will use the ether type, which is 0x7261. This is the layer 2 ether type it will use. If we will configure as a layer 3, that time it will use either IP protocol 99, either it will use UDP port number 29281, basically. So you have to remember these details, guys. This is your HA1 and HA2 interface. Now we have a HA3 interface as well, guys. So your HA3 interface is come in a picture. So let's suppose this is my HA3 interface and I'm running both the firewalls in active unit. So when you will configure, when you will run your firewall in active, that time your HA3 link come in a picture. And that HA3 link we used for if your firewall 1 wants to communicate with firewall 2, or they will send some data traffic, because in HA, active HA, there is a concept of session owner and there is a concept of session setup. So if your session owner and session setup wants to communicate with each other, that time they will basically exchange the user's packet through HA3 interface, guys. Just remember. So that's the use of your HA3 interface in your active design. Now, let me just go in little bit depth here, guys. So through control link, what they will exchange hello messages, your heartbeat messages, your configuration synchronization, and apart from this, they will also exchange some other management plane capabilities, which is your IPT user mapping, user to group mapping, and that thing is done by the user ID daemon, guys. Your DNS cache information, your DSCP information, and that thing is done by the DSCPD daemon. And your FIP tables, which is done by the route D daemon. So this is the information which they will exchange your through HA1 interface, because I have seen in interviews they will ask what are the information is exchanged between firewall 1 and firewall 2 through HA1 interface, guys, and you have to answer like that. This is the information: hello messages, heartbeat messages, configuration sync, IPT user mapping, DNS cache, DSCP, release time, and all these details, and FIP tables. I'm not going with the HA1 backup here. Now, why we use this HA2 interface? Through this HA2 interface, we will exchange the session table or flow table or a connection table. Means we will do the session synchronization, your MAC address table, your virtual MAC address table, your DOS block table, your virtual MAC address, guys. This is not a table. This is the MAC address table. Your IPsec assay detail, SCTP association, and your ND table when we will run your firewall in virtual wire deployment. Okay. So this is the information which is exchanged through HA2 interface, guys. So this is all about your HA1, HA2, and HA3 interface in your Palo Alto firewall. Now, how passive firewall know there is a config change in your active device? How? Because this is also most popular question, guys. I'm just keeping this question very small, guys, and I will go here now. If you know, everyone know who is basically working little bit on your Palo Alto firewall, you will know we will do all kind of configuration in your active device, right? And all the configuration is synchronized with the active device, with passive device. How they will basically get to know there is a config change. So guys, as I have mentioned, through HA1 interface, they will exchange this hello messages, right? Now this hello messages, what it is having some kind of MD5 hash value of your configuration file. So because you know this device, it is having one local configuration file or local candidate configuration file. And this device also have a local candidate configuration file. So what it will do when he will send the hello messages, what it will take this local candidate config file, it will run the MD5 hashing algorithm on this file, and he will get one number. Let's say here get this number A, B, C, D, E, F. This is the number he will get, right? He will send that value towards this hello message received by the passive firewall through HA1 interface. Now, what passive firewall will do? He will also have the local configuration file. He will also run the hash, MD5 hash. He will, let's suppose he get the value which is A, B, and after that he is getting something else. If there is a config change, which means whatever configuration file we are having here, if and whatever configuration file we are having here, if there is a change with regards to the configuration, what they will do, this hash value will change. If this hash value will change, your passive device gets to know there is some config change happens, and after that he will request firewall 1 to synchronize the configuration. That's how they will do the config sync, guys. And just remember one thing, your config sync is always done by the HA1 link only. If you have a HA1 backup interface, guys, that interface will not used for configuration sync. That interface is only used for exchanging the heartbeat messages and hello messages. Your config sync is always go through the HA1 interface. Just remember. This is also an interview question. They will ask you, they will confuse you. Can firewall 1 and firewall 2 do the config sync through HA1 backup interface? You have to tell straightforward, no. Config sync is only happens through your HA1 interface. Now, if I'll go here, let me just show you something here. So right now I'm on my firewall 2, and let me just take the access of my firewall 1 as well. This is the wrong device I'm opening. So let me just open this one. It will open automatically. Generally, what we used to do, we always used to run, there is a one command which is known as less mplog haagent.log. This is the log file we will check, guys, always. And in this log file, you will see they will exchange these capabilities messages, and below this capabilities message, you will have this hello message, right? So you will get these kind of values there. This is the hash information, guys. This kind of hash information they will exchange. Okay. This information. HA2 backup MAC address details, all things you will see here. Okay. If there's any change, you will get the mismatch with regards to this hash values. So I'm just showing the old log, guys. These are not the latest log. Okay, because I have just configured these devices in the morning. So this is the daemon file which we have to check. So if you want to check the live logs, always run the command like this: tail follow yes mplog hagent.log. If you run the command in this way, you will get the live logs, what's going on right now. If I'll do one thing here, let's suppose, let me log in on my firewall one. Let me just do some config change. Let's see this particular thing, how this thing happens. So let me just log in and I will just add some configuration here and we will check the HA agent daemon logs here. So I also got the access of my firewall one. Let me also run the debug here. Tail follow yes mplog hagent.log. This is the daemon, guys, who will take care of the H related functionality. You will see I am running active right now. Local is active secondary, another one is active primary. This is the firewall who is a active primary right now. So let's see. So what I will do, let me go into objects. Let me add few objects here. Let me just add here one test object 1.1.1.1. Let me just do the commit now. I will do the commit. Now you will see here commit is going on. We will monitor the things here. Now you will start seeing some logs here, guys. See, they are exchanging these hello messages, right? Even though if you want to see details in a broader way, what I can do, I can also do one more thing here. Let me just capture the packet on my HA1 interface, which is Ethernet 1x3. So capture is going on, guys. Wait here. We will got the debugs here after some time because right now commit is going on our first device. Once this commit will complete, we will see the details. So we will wait for some time, guys. Let's see this thing practically. Right now, see config is in synced right now. Just wait here. It is 0%. It is doing some validation, guys. If you don't know the commit, let me just give you some little bit information of commit, guys. So in Palo Alto Firewall, when we run the commit command, what will happen? Commit process will go through three phases: phase 0, phase 1, and phase 2. In phase 0, it will check where it has to store the configuration and all, right, for all the objects. In phase 1, it will do the validation. In phase 2, it will basically actually implement the things. You will see here 98% right now. So we will wait for some time. You will get to know here after some time there is some little bit unsynchronization, right? That's why I'm just running the refresh here. It's in 99%. So let's wait. See, session synchronization is in progress. How this happens automatically? If you go here into these log files, see the log file. Control C. You will see config MD5 checksum. This is the MD5 hash value they will exchange basically. This is the previous one. This is the new one. That's how they will get to know there is a change. There is a config change, basically now they will start the synchronization. So they will send this kind of hash values, guys. Okay, what you will get the details here. Got the new config MD5 hash, this value, new MD5 hash is this value, these values are changed, right? If these values are changed, which means set new MD5 configuration comparison. Okay, we were in sync and now we are out of sync. Now auto commit will happen. What is this auto commit, guys? This is the cron jobs run by the Palo Alto firewall, because when this cron job runs at the multiple places, guys. Okay, auto commit will run and your session synchronization will happen between firewall 1 and firewall 2. So this particular hash value they will send and they will compare. Okay, so this will answer your how passive firewall know there is a config change in your active device, guys.